Okay, so this video is going to look at two examples of how we can solve problems using trig functions and finding the derivatives of trig functions. So the first thing we're going to do is take this function y equals the cosecant of x, and we're going to get the second derivative. So if I'm looking at y equals the cosecant of x, we could use the formula that we created with the last video, or with the previous video, but I'm just going to derive this from scratch. So I know that this is 1 over the sine of x. And I know that then y prime is going to be sine squared of x. The numerator is going to be sine of x times 0, which is going to give me 0. And then I'm going to subtract 1 times the derivative of the sine of x, which gives me cosine of x. Okay, so this really can be rewritten as negative cosine of x over sine of x times the sine of x. Okay, and then that can be rewritten as negative cosine of x over the sine of x times 1 over the sine of x. Okay, and then y prime is really negative cotangent of x times the cosecant of x. All right, so now we're ready to take the second derivative. Second derivative in this case is going to be product rule. So I'm going to take the negative cotangent of x times the derivative of the cosecant of x plus the cosecant of x times the derivative of negative cotangent of x. Okay, so when I go to clean that up, that's going to give me negative cotangent of x. Okay, from our proofs from earlier, we know that that's negative cosecant x cotangent x plus your cosecant of x times negative cotangent of x is going to be negative cosecant, so negative negative is going to make it cosecant squared of x. So in the last step, when I go to simplify everything, I'm going to get right here, this is going to be a cosecant cubed of x. Negative, negative, make it positive. Cosecant of x, cotangent of x squared. Okay, so that is the second derivative. Okay, the next example we're going to look at is if you're asked to find the equation for the lines that are tangent and normal to the graph of this function at x equals 3. Okay, so to do that, let's find the normal line first. So to find the normal line, we're going to start off with y equals x squared sine of x. And so then dy dx is going to be, all right, it's product rule. So I'm going to take x squared, that's going to make it 2x times the sine of x plus x squared times the cosine of x. Okay, so we want to know what the slope is at 3. So this is the general formula for the all functions at all points. So this is derivative of all points, but we want to know just at 3. So that's going to give me 6 times the sine of 3 plus 9 times the cosine of 3. And if you plug that into a calculator, make sure you're in degree mode or radian mode, negative 8.063. Okay, so that gives me a slope. Now I need to find my y-intercept, so I'm going to take y equals mx plus b. I'm going to plug negative 0.8063 in. I'm going to plug in, my x value is 3. The only problem with this, I don't know what the y value is. So I need to go back up here and I need to plug y in at 3. So I know what the y value is in the original function. So that's going to be 3 squared times the sine of 3, which equals 9 times the sine of 3. And 9 times the sine of 3 comes about to be 1.270. So that means that's my y value of 1.270. So now if I divide both sides, actually I take that back, I'm not going to divide, I'm going to add whatever 8.8063 times 3 is. I'm going to add 0.8063 times 3 to both sides. And that's going to cancel. So if I take 1.270 plus 8.063 times 3. That's going to give me 25.459. Okay, and so now I'm going to be able to get a linear equation here of y equals, my slope was negative 0.8063x plus 24.46. Okay, so that would be my tangent line. Okay, now if we want to find the normal line, same work, we're going to work with that same point, which was 1.270, but instead of our slope being negative 0.8063, it needs to be negative 1 over negative 0.8063. So that's going to end up being a slope of 0.124. So when I go y equals 0.124x plus b, now I'm going to plug this point in, so that's going to give me 0.124 times 3 plus b equals 1.270. So now I subtract this from both sides. B comes out to be 0.898, and therefore my normal line is going to be 0.124x plus 0.898.